Welcome to Severstal, Columbus, America's next-generation steel plant. With the industry's most state-of-the-art technology and an all-encompassing customer-centric vision, Severstal Columbus is a unique resource to meet a growing demand for steel in the southern U.S., an advantage that reflects well on the larger picture. The Severstal story is one about a global, Russian-based mining and metals organization with stateside facilities in Maryland, Michigan, Mississippi, Ohio, and West Virginia, and abroad in countries as diverse as Russia, Italy, France, and the United Kingdom. By combining its vast expertise and resources in North America and throughout the world, Severstal can deliver unmatched strength, support, and value to its customers. In fact, Severstal's global integration has made it one of the world's leading steel-producing companies. So now, the next chapter begins. Severstal Columbus's 3.4 million-ton steel mill resides on a 1,400-acre mega site near Columbus, Mississippi, a crossroads for an abundant transportation network. While 19 of the 25 Southern automakers' assembly plants are located within 450 miles of the Severstal mill, automotive is just one of the many steel-consuming industries that call the South home. Since Severstal announced its new steel mill in the Golden Triangle of Mississippi, over 3 million new tons of steel-consuming industries have moved to Mississippi, Arkansas, and Alabama alone. On October 3, 2005, Severstal Columbus broke ground on a truly innovative, state-of-the-art facility, merging compact strip production, or CSP technology, with integrated finishing mill equipment. The result is a cost-effective, higher-quality product in a wider range of grades. Severstal's steelmaking process begins in the scrapyard. Severstal uses a richer metallic mix, including high-grade scrap, pig iron, and hot briquetted iron, or HBI. A specific customer's order dictates the precise scrap mix. The journey from scrap to steel starts when the specified scrap mix is transported to the facility's melt shop and released into a massive 180-ton clamshell bucket. An overhead crane descends from above, lifts the bucket of scrap, and hauls it to the facility's electric arc furnace, or EAF. The EAF comes alive with a rumble that seems to shake the facility's very foundation as the clamshell doors on the bucket open, releasing the scrap into the furnace. The furnace is the heart of the operation. Its presence is heard and felt throughout the entire plant. As the furnace lid swings closed, a single electrode is lowered into the scrap. The spectacle of cascading sparks creates the visual counterpart for the thunderous din of the furnace. Electrical arcs heat the contents to approximately 3,000 degrees Fahrenheit, melting the scrap into a heat of molten metal in under 40 minutes. The furnace is then tapped, its glowing contents poured into a 165-ton capacity ladle and transferred to the facility's ladle metallurgy furnace, or LMF. Here, alloying elements are added to achieve the correct chemical composition for the grade of steel specified by the order. From the LMF, the ladle of molten metal is moved to the thin slab caster. A bottom spout allows the ladle to pour the molten metal into a tundish or reservoir and ultimately into a casting mold. Descending nearly 7 stories, the molten metal traverses down the mold's walls, cooled by water along the way, which hardens the metal into a semi-solid slab of steel. At the bottom of the caster mold, the slab is sheared to a length corresponding to the customer's order and moved slowly into the facility's tunnel furnace. Nearly the length of 3 football fields, the furnace heats the slab to a consistent hot rolling temperature of around 1,900 degrees Fahrenheit during its 15-minute journey to the hot mill. Leaving the furnace, the slab enters the 6-stand hot mill, where the 2.5-inch slab is reduced, as specified by order, to thicknesses from 1/2 inch to as light as 0.054 inch, or about the thickness of a U.S. dime. Once reduced to the specified gauge, the slab continues over a runout table where the steel is cooled by water spray. At the end of the line, it is coiled and either shipped as hot rolled bands for use in auto body frame components or pipe and tubing applications, or it is sent to downstream equipment for additional processing. The first downstream finishing process is pickling. The coiled hot band is uncoiled and passed through a series of hydrochloric acid and water rinse tanks to remove iron oxide from the surface. Upon request, oil can be applied to the surface to help inhibit rust formation. Pickled and oiled products are typically used in heavy stampings and electrical panel boxes. Severstal's continuous pickle line is atypical to most low-cost steel producers. That the plant's pickle line is directly coupled to a 5-stand tandem cold reduction mill is most remarkable. As one of only 4 cold mills coupled to a pickle line in North America, Severstal Columbus is more efficient than many competitors due to lower yield loss. Each cold mill rolling stand successfully reduces the thickness, with gauges ranging from as heavy as 0.075 inch, or the approximate thickness of a U.S. nickel, to as light as 0.014 inch, again depending on the customer's order. The mill features a closed-loop gauge and shape control system and a 360-degree rotating inspection table to ensure the highest quality surface and shape. At this stage, the coil is a full hard cold roll product primarily sold for roof decking. Batch annealing, a value-added process for full hard cold roll, restores ductility for improved stamping and forming. Coils are stacked and cooked in hydrogen atmosphere furnaces. After about 3 days in the furnaces, the coil moves to the temper mill, where the customer's specifications for surface finish and mechanical properties are met. This product is sold as fully processed cold roll and is used in lawn and garden products, appliances, tubing, and shelving. For a greater degree of corrosion resistance, full hard cold roll may have a coating of zinc applied at the continuous galvanizing line. The full hard coil passes through a cleaning section, vertical annealing furnaces, and a molten zinc pot. Vertical ovens bake the zinc to the coil. In-line tempering and tension leveling ensure the best surface and shape. Rust inhibitors can be added at this stage if the product will not be painted. Automotive applications often require galvanneal instead of galvanized. The result is a dull matte appearance, allowing for improved paintability. Typical applications for galvanized and galvannealed coils are building panels, HVAC uses, household appliances, automotive bodies, and outdoor applications. Severstal Columbus's finished products can be shipped by truck, rail, or even barge to customer plants. Merging exciting CSP technology with integrated mill equipment and enjoying a strategic location in the heart of a southern U.S. manufacturing boom, Severstal Columbus is poised to meet the needs of steel-consuming industries today and in the future. The company's Phase 2 expansion more than doubles the capacity of the mill, increasing the initial annual production of 1.7 million tons to 3.4 million tons of high-quality flat-rolled steel. Severstal has all the capabilities you need and the resources you want. Our strength is international, but our service is refreshingly local. Turn to us for all your steel buying needs, and we'll show you the difference that one name can make. Severstal, equipped and dedicated to changing the way steel is made and sold.